Hello everyone, in this video I am going to explain metamerism and functional group isomerism. First metamerism, or what are metamers, or first functional group isomers. What are functional group isomers? Two or more molecules which have same molecular formula same as usual, but different functional group. Functional group are different. Such molecules are said to be functional group isomers. Molecules which have same molecular formula but different functional group are called functional group isomers. That first example alcohols and ethers. Alcohols and ethers are functional group isomers. If you see with molecular formula C3 or C2H6O, with this molecular formula I can write two isomers. They are CH3 CH2OH and CH3 OCH3. Okay. So verify number of carbon atoms in each 2. Number of hydrogen atoms are 6. Number of oxygen atoms are 1. Same molecular formula but functional group different. Here what is functional group? Functional group is alcohol functional group here. Here functional group is ether. So thus one is alcohol, other is ether. So IUPAC names are ethanol and methoxymethane. So its IUPAC name ethanol, eth plus an plus ol, and methoxymethane. Both are functional group isomers. Okay, alcohols and ethers. Next, second one, aldehydes and ketones. Aldehydes and ketones also functional group isomers. Aldehydes and ketones. Alcohols, ethers and aldehydes, ketones are functional group isomers. So alcohols, ethers, functional group isomers. Example this one. Aldehydes and ketone C3H6O. With this molecular formula I can write two molecule, one aldehyde CH3 CH2 CHO. Other is CH3 OCH3. CH3 C double bond O CH3. Verify number of carbon atoms in each 3. Number of hydrogen atom 6 only. Number of oxygen atom 1. 1, 2, 3 carbon atom. Probe single bond between those carbon atoms. Single bond AN. CHO functional group all propanol. And CH3 C double bond O CH3. 3 carbon atoms. So probe single bond between 3 carbon atom AN, C double bond O functional group ON. Propanol and propanone functional group isomer. Molecular formula same, functional group is different. Third, if you see carboxylic acids and esters. Carboxylic acids and esters. Carboxylic acids and esters also become functional group isomers. CH3 CH2 COOH. Propanoic acid. Number of carbon atoms are 3. Number of hydrogen atoms are 6. Number of oxygen atoms are 2. With the same molecular formula we can also write ester CH3 C double bond O OCH3 or COO or ester or COOH, carboxylic acid. IUPAC name 3 carbon atoms are there. So prop single bond between 3 carbon atom AN, COOH functional group oic acid, propanoic acid. So here methyl 2 carbon atoms in parent chain. Eth AN O8. Methyl ethanoate. or you can also call methyl acetate. Both are functional group isomers. Molecular formula same or not? Yes, molecular formula same, functional group different, so functional group isomers. If you see nitroalkenes and alkyl nitrates, nitroalkanes and alkyl nitrates, alkyl nitrites are functional group isomers. For example, CH3NO2, nitromethane, and CH3O N double bond O. This is what? Nitromethane. 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 And this is what? Methyl nitrite. Methyl nitrite. Both are functional group isomers. In the similar way, cyanides and isocyanides. Cyanides and isocyanides. Cyanides and isocyanides also functional group isomers. See, CH3CN. Number of carbon atoms 2. With the same 2 carbon atom, I can also write like this, NC. Your nitrogen plus carbon minus. This is methyl cyanide. Molecular formula same, 2 carbon atom, 3 hydrogen atom, 1 nitrogen atom. Molecular formula same, methyl cyanide. Methyl cyanide. And this is methyl isocyanide. Methyl isocyanide or methyl isonitrile. Methyl ethane nitrile, methane isonitride. So all these are functional group isomers. Next we have 2 more examples for functional group isomers. First, alcohols, phenols, alcohols and ethers. Remember, alcohols and ethers, aldehydes, ketones, carboxylic acids, esters, nitroalkanes and alkyl nitrates, cyanides and isocyanides, primary, secondary, tertiary amines, alkynes and alkadienes, and alcohols and phenols. All these are 8 functional group isomers possible. First take this one. Next, 6th one, primary, secondary and tertiary amines are functional group isomers. Functional group isomers to each other. Primary, secondary, tertiary amines are functional group isomers to each other. Example, propanamine, CH3, CH2, CH2NH2, primary amine. Only one hydrogen of ammonia replaced by alkyl group, primary amine. Primary. Name is propanamine. Next, with the same molecular formula, how many carbon atom? 3 carbon atom, 1, 2, 3. Hydrogen atoms, 7 plus 2, 9. And the nitrogen is 1. With the same molecular formula, I can write another amine, that is secondary amine, NHCH3. Verify carbon atom, 3 carbon atom, 9 hydrogen atom, 1 hydrogen. This is secondary amine because the 2 alkyl groups, only 1 hydrogen. This is N-methyl ethanamine. Its IUPAC name, N-methyl, N on nitrogen, methyl group, ethanamine. Next, third one, CH3, here CH3. tertiary amine. So on nitrogen, methyl, second time methyl, N comma N, dimethyl, N comma N dimethyl, N comma N dimethyl, only one carbon atom in parent chain, methane amine. N comma N dimethyl methanamine is IUPAC name. Primary, secondary, tertiary amine. Molecular formula same, C3H9N only, but functional groups are different. How will we say these are functional group isomer? They have different characteristic properties. When you see practically, they have different characteristic properties, hence they are said to be different functional groups. Next, seventh one, alkynes and alkadienes. Alkynes and alkadienes are functional group isomers. For example, C3H4 with molecular formula C3H4, CH3, C triple bond CH, 3 carbon atom, 4 hydrogen atom. Pro plus ine, propine, and other is CH3 cumulative diene, CH2, double bond CH2, highly unstable but possible to write. So prop 1, 2 diene, a cumulative diene. So these two are this is alkyne, this is alkadiene, 2 times double bond alkadiene. Both are functional group isomers. And lastly, eighth example, alcohols and phenols are functional group isomers. Alcohols and phenols also functional group isomers. For example, benzyl alcohol, 2 phenyl group, this one, OH group attached to aliphatic carbon, not a ring carbon, so this is alcohol. Benzyl alcohol, its name is benzyl alcohol. Or if you see this one, molecular formula same, total number of hydrogen atoms are 7 hydrogen atom, 5 plus 3, 8 hydrogen atom, 7 carbons, 8 hydrogens, 1 oxygen. Molecular formula same, but this is called cresol, orthomethyl phenol. So this is what functional group isomerism. This is phenol, so O-methyl phenol. Its general name is orthomethyl phenol. Common name is cresol. O-cresol. This is phenol, this is alcohol. Different functional group. They behave differently. They have different characteristic properties. So they are said to be functional group isomers. Or you can take paracresol, metacresol, orthocresol, any cresol, those are phenols, and this is alcohol. Because OH group not directly attached with benzene, not directly attached with aromatic carbon, it is attached with aliphatic carbon. So these two are also functional group isomers. Next, metamers. So take this one. Next, metamers. What are metamers? 2 or more molecules which have same molecular formula, same functional group, molecular formula same, functional group same, but differ in, those molecules are differ in size of alkyl group, length of alkyl group on either sides of bivalent functional group. So you know bivalent functional groups have two valency, on both sides alkyl chains are possible. So in metamers, size of alkyl groups on bivalent functional group are different. Such molecules are metamers. What are metamers? 2 or more molecules which have same molecular formula and same functional group, but they are differ by length of alkyl groups on both the sides of either sides of bivalent functional group. Okay, what are bivalent functional group? Ether, O and keto group, bivalent functional group. Ester group, bivalent functional group. Amines, bivalent functional group. Thioethers also bivalent functional group. Of course, thioether not present for us. See some example for metamers. For example, first ethers. In ethers, bivalent functional groups are. In ethers, bivalent functional groups with C4H10O. The C4H10O, CH3, CH2, CH2, OCH3. Verify number of carbon atom. Number of carbon atoms are 4, hydrogen atoms are 10, oxygen atom is 1. And if you see CH3, CH2, O, CH2, CH3. Here 4 carbon atom, 10 hydrogen atom, 1 oxygen atom. Both are ether, both molecular formula same, both functional groups also same, both are ethers. But on one side propyl group, on other side methyl group, ethyl here, propyl group here, and this is methyl group here. On one side methyl group, here ethyl group one side and ethyl group another side. Molecular formula same, functional group same, but differ in alkyl group on both the sides of bivalent functional group. Such molecules are metamers. These two are metamers. Next example, if you see ketones, for ketones. In ketones, functional group isomers, if you take C5H10O molecular formula, so here CH3, CH2, double bond O, CH3, other molecule CH3, CH2, C double bond O, CH2, CH3. Once verify number of carbon atoms in both 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Hydrogen atoms 10 only in both, oxygen atom 1. Here if you see this molecule seems to functional group position different, 1, 2, second position, here functional group 1, 2, 3. They are seems to be position of functional group different. Of course, they are position isomers, they can said to be position isomer, but rather than they are metamers. If you see priority RTF MCP. So first verify for they are metamers. If they are metamers, you cannot say they are position isomers. What are metamers? On bivalent functional group, alkyl groups are different. Ethyl, here propyl and methyl. So since metamerism is dominated over positional isomerism, they are said to be what? Metamers, not position isomers, they are metamers. Okay. Next example in esters. Next example, esters. Esters, 1 minute. Right, esters. So CH3, CH2, C double bond O, CH3, OCH3. So this is functional group. Here methyl and ethyl. So if you write like this, CH3, C double bond O, CH2, CH3. Here this is what its IUPAC name is, methyl 1,2,3 propanoate, methyl propanoate, and it is what? ethyl ethanoate. Ethyl is substituent. Here methyl is substituent. This is what? Ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. Both are functional group isomers. Next, secondary amines. Secondary amines also contain bivalent functional group. If you write CH3, CH2, CH2, NHCH3, and another molecule CH3, CH2, N, CH2, CH3, here hydrogen. So molecular formula say both have 1, 2, 3, 4, 1, 2, 3, 4, 4 carbon atom, hydrogen atom same, nitrogen atom same. This, its name is N-methyl, a nitrogen methyl group is there. So N-methyl propanamine. Prop plus N plus amine. N-methyl propanamine. This is N-ethyl ethanamine. N-ethyl ethanamine. N-ethyl ethanamine. These two are functional group isomers. Sorry. What? Yes, metamers. So functional group same, secondary functional group. Secondary amine functional group. Functional group same, molecular formula same, but alkyl groups present on functional group different. Here ethyl, here propyl and methyl. Okay, these are metamers. So next I will give two examples. Those two examples give full clarity regarding structural isomerism. Okay, next. Example C4H10O. C4H10O. With this molecular formula, what is the double bond equivalence? Double bond equivalence is 4 carbon atom, 10 nitrogen atom by 2 plus 1. That means 4, 10 by 2, 5 plus 1, that is equal to 0. No double bond, no ring. No double bond, no ring. How many structural isomers possible for this? This is this is C4H9OH. Alcohols are possible with only 1 carbon atom. Alcohols possible, ethers possible. Alcohols and ethers. Alcohol ethers have same molecular formula. With 1 oxygen, aldehydes ketones present, but aldehydes ketones formulas with 4 carbon atom C4H8O. This is C4H9, C4H10. So aldehydes ketones are not possible with this molecular formula. With this molecular formula, alcohols and ethers are possible. Alcohols, ethers, this formula. Aldehydes ketones, this formula. Of course, both contain 1 oxygen atom. Both contain 1 oxygen atom. So I can write aldehydes, alcohols first. So with above molecular formula, alcohols and ethers are possible. Alcohols and ethers possible. Alcohols and ethers possible. So in alcohols 4 carbon atom alcohols. So CH3, CH2, 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 OH. 1. Next CH3, CH3, CH2, OH. This is another. CH3, CH2, CHOH and CH3. This is third. CH3, COH, CH3, CH3. Verify for carbon atoms in all. In all, number of carbon atoms are 4 only. Number of carbon atoms are 4. Number of hydrogen atoms 10. If you verify number of carbon atom, number of hydrogen atoms, 4 carbon atom, 10 hydrogen atom, 1 oxygen atom only. All these are structural isomers. Next, With ethers, I can write ether with this molecular formula, ether. CH3, CH2, O, CH2, CH3, this is 1. Next, CH3, CH2, 1 minute. Yes, here CH3, CH2, CH2, OCH3. Okay, this is another. Okay. Okay, these two are ethers possible. 4 carbon atom and 10 hydrogen atom and 1 oxygen atom. So if you say this is E and this is F. Here what are A and B? A and B, carbon chain length, first 1, 2, 3, 4, 1, 2, 3, 4, carbon atom same. So parent chain length is same, parent chain arrangement same. So A and B are position of functional group different. Position of functional group first carbon, position of functional group second carbon. A and B are position isomers. A and B are what? Position isomers. Next, if you see A and C, 1, 2, 3 parent chain, 1, 2, 3, 4. So chain different. A and C are what? If carbon chain is different, parent chain 1, 2, 3, 1, 2, 3, 4 carbon atom in parent chain, they are what? Chain isomers. Chain isomers. A and C are what? Chain isomers. If you see any set of this one and this one, for example A and E. A and E. A and E are what? One is alcohol, other is ether. Functional groups are different. So they are what? Functional group isomers. Functional group isomers. Functional group isomers. If you compare another molecule, I am writing another molecule, CH3, C, CH3, CH, OCH3. Okay, so consider this as F, FG. What are F and G? F and G. See, both have same molecular formula, same functional group, chain length same, 3 carbon atom, 3 carbon atom, 1 carbon atom, 1 carbon atom. Chain length also same molecular formula, same functional group, same length of carbon chain. All are same. So same length of carbon chain on both sides mean they are not metamers. This is 1, 2, 3 carbon atom, 1, 2, 3 carbon atom. They are what? Position isomers. This is important. So methoxy group present at second carbon, 1, 2, 3 parent chain, on second carbon methoxy, 1, 2, 3 parent chain, on first carbon methoxy, second carbon methoxy, first carbon methoxy. They are not metamers, they are what? Positional isomers. Positional isomers. Thus we identify positional isomers, chain isomers, functional group isomers. Okay, in next example I will cover metamers, functional group isomers, ring chain isomers. Take this example. Next example, C3H6O. C3H6O. With this molecular formula, what is the double bond equivalence for this? Double bond equivalence is the number of carbon atom 3, number of hydrogen atom 6/2, nitrogens absent plus 1. Double bond equivalence is 1. Therefore, one double bond equivalence 1 means one double bond or one ring possible. One double bond, one ring possible. So here oxygen is present. So which functional groups are present? Alcohols. In alcohols, double bond with alcohol. Compare number of carbon atom 1, 2, 3, 3 carbon atom, 6 hydrogen atom, OH. Okay. Alcohol's general formula CnH2n plus 2, C3H8O. But in alcohols, double bonded alcohols have same aldehydes ketones formula. Enols are similar to aldehydes and ketones. They are differ from alcohols. Okay, enol. Next, I can also write like this: CH3 CH double bond CHOH. This one also possible, or CH3 COH double bond CH2. 3 possible. 3 carbon atoms with alcohol, cyclic, 1 cycle, and OH. That's 4 possible. 4 possible. I will write here: alcohol, cyclic alcohol. Okay, so label they are A, B, C, and D. Ethers. Say ethers. In ethers, CH2 double bond CHOCH3. Carbon atoms are 3, hydrogen atoms are 6, oxygen is 1. Only this is possible. Next, cyclic ethers, 3 carbon atom with oxygen. 3 carbon atom with oxygen. This one possible. Next, reduce ring size, then a branch like this. This is possible. Okay, aldehydes only open chain aldehydes are possible, cyclic not possible. Cyclic aldehydes are not possible, parent chain. Okay, next, ketones, only one ketone, cyclic ketone not possible with this formula. Cyclic ketones are possible, but with this formula, cyclic ketones are not possible. Like this. Okay, if you compare A, B, C, D, and I am label this as E, F, and this is G, H, and I. A and B are what? Carbon chain, same 1, 2, 3, 1, 2, 3. They are not chain isomer. They are position isomers. A and B are position isomers. A and B are positional isomers. Okay, clear. Next, A and D are ring chain isomers. All possible isomers I am writing, not all isomer. All possible different kinds of isomers. Position isomers completed. Next, if you see A and E are here ether functional group, here what? This is alcohol function, enol, alcohol functional group. So A and E are functional group isomers. I am writing different types of isomers, not all isomers. Okay. If you see A and H, A and H, A and HR. So A is alcohol enol, and H is or I is, H take HRI. One is keto form. This is keto form, this is enol form, keto-enol isomerism. One is keto form, other has enol form, keto-enol. This is also called as tautomerism. Tautomerism, atropisomerism, we are not discussed yet. our next isomerism, last isomerism in structural isomerism is tautomerism. A and I are tautomers. One is keto form, other is enol form. Keto-enol isomerism, that is tautomerism. In my next video, I will explain what is tautomerism, important concept in competitive. Okay, hope you understood well. Take this.